Okay, so yesterday we have started our second chapter, that is mechanical properties of fluid, and we have studied the basic concept of fluid. What is fluid? Okay, then we have discussed what is fluid. Then we have studied the characteristics of ideal fluid. There were four characteristics. Then we have covered the characteristics of fluid. Okay, and then we have studied an expression for what pressure due to the liquid column in a container, and we have removed that expression, and that is nothing but equal to h rho g. Okay, where h is the height of a liquid in the column, then rho is the density of that liquid, and g is acceleration due to gravity. Okay, now if you see the fluid which is there in this container, the fluid which is there in the container is at rest. Okay, now whatever yesterday's derivation also, if you see, we had seen the expression for the fluid which is at rest, and the study of such branch of the physics which deals with the fluid which is at rest is called as hydrostatics. Okay, why should we learn this? If you see, we have number of dams in our country which stores a huge amount of water. Okay, so water which is stored in the dam is at rest. So what will be the pressure exerted by that water on the wall of the dam? Okay, what will be the pressure of the water on the surface of that earth which is undercovered by the dam? Okay, so there are many things we have to know. So this chapter is very important from application point of view. Okay, now today what we are going to learn, we are already familiar with it. That is nothing but atmospheric pressure. I hope you know this atmospheric pressure very well. So what is atmospheric pressure? Pressure exerted by atmosphere is called atmospheric pressure. Very simple definition. But what is that? What is atmospheric pressure? Okay, so atmospheric pressure means, first we will understand what is pressure. Again, by the definition of the pressure, what is pressure? It is force acting per unit cross sectional area of a body. Now this is a cross sectional area of this beaker. Okay, and inside the beaker there is certain volume of the water. Okay, and this volume of water is having certain weight. Let that weight be mg. It is mg mass into gravity. Okay, so due to that weight, this volume of water is applying certain force on this surface area. Okay, so that is called as the pressure. So if I increase the height of the water, if I fill this beaker completely, pressure will be more. If I decrease the level, then right now it is 200 ml of water. Okay, if I increase it, pressure will increase. If I just keep 100 ml of water, pressure will decrease. Okay, so it depends upon the volume. So it depends upon volume means in this particular container, it depends upon the height of that. Okay, so first we are going to study what is pressure. Pressure is nothing but, pressure of air is nothing but a force that is exerted on the surface of earth. A force that is exerted on the surface of earth by an air column. By an air column is called as a air pressure. Okay, same way if we see on the surface of the earth, surface of earth consists of atmosphere which has the different layers, and this atmosphere which contains different fluid gases. Okay, it has certain amount of weight. The gas which is there in our atmosphere, it has certain amount of weight, and that weight is exerted on the surface of earth. That weight is exerted on surface of earth. Due to that, there is a pressure on the surface of earth that is called as atmospheric pressure. Okay, what is atmospheric pressure? pressure exerted due to the weight of the atmosphere on the surface of the earth is called as atmospheric pressure. As we have studied here, the pressure exerted by this liquid water on this surface of the beaker is a pressure due to this liquid. Same way, the atmosphere that exerts the pressure on the surface of earth is called as atmospheric pressure. Okay, so we can define the atmospheric pressure like this, that atmospheric pressure is nothing but a pressure exerted by a air column starting from one point and ending on the surface of earth is called as atmospheric pressure. Now, this atmospheric pressure at different level on the surface of earth is different. Okay, it is highest on the sea surface. Sea surface, if you see, go on the beach, seashore, at that place atmospheric pressure is highest. And as you go away from at higher level from the level of the sea, the atmospheric pressure goes on decreasing. Atmospheric pressure goes on decreasing. Why? Because as we go higher and higher and higher, the density of the air decreases. Okay, and so the weight decreases. As a result, the pressure exerted by that decreases. As we have yesterday only we have derived the expression for the pressure is nothing but what? H rho g. As rho decreases, as density decreases, so that pressure goes on decreasing. Atmospheric pressure goes on decreasing. Okay. Now, if you see, go above the height of 8 kilometer above the surface of sea level. From the sea level, if you go above 8 kilometers, okay, and at 8 kilometer, the density is very negligible, and hence the atmospheric pressure is very less as compared to the other gas pressure. So we say that there is a vacuum. There is vacuum. Okay, what is vacuum? If a gas pressure is less than that of atmospheric pressure is less than that of the gas pressure, then we say that there is a vacuum. Got it? Perfectly, we can define the vacuum as a thing or the empty space where there is nothing, no atom, no ion, nothing is present. Such a space, such a void space is called as vacuum. But practically, it is considered where atmospheric pressure is less than that of the gauge pressure. A gas pressure is called as the vacuum. Okay. I hope you have understood the concept of the atmospheric pressure. Now we are going to see what is absolute pressure and gauge pressure. Okay. So let us see this atmospheric pressure and gauge pressure. Okay. Consider this is a vessel containing a water, filled with the water. And inside this vessel had emerged one cylindrical vessel, cylinder in it. Okay. And let h be the height of the cylinder, and I am measuring this height. I don't know what is height, so I am measuring this height from the base of this vessel. So from base of this vessel, I have given this name as x2 and this as x1. So as I am measuring from here, so x2 is smaller than x1. Okay, for your see, as I am measuring from here, okay. So this is the value of x2 and this is the value of x1. So x1 is larger than x2. Okay. Then, as this vessel is inside the water, so there are the forces which are acting on this vessel. So, which are those forces acting on the vessel? Let us analyze this force. Okay. Now, this is the top surface of the vessel, this cylinder. So, on the top surface, the force acting is F1 due to this weight of the water. Okay. Due to this water which is present at top of that vessel, that water is exerting certain force on this top surface area of this vessel. Similarly, from the bottom, if you see, there is water below this vessel, so that this water is also exerting certain force on this surface. Exerting certain force on this surface. And as there is certain amount of water inside this vessel, so that vessel water has certain weight, okay, and that weight mg is that acting downwards, okay. So if we just write the equation of the forces, or if we try to write the forces acting on it, we get what? This force F2, which is acting in upward direction, and this two force F1 and weight mg is down, acting in downward direction. So this force F2 balances F1 and the weight of the water. So I have written here F2 is equal to F1 plus mg. So whatever is the net effect of this force plus this weight is equal to the force applied by lower surface of this water. Okay. Now let the pressure as force. This is the force which is acting here. So there will be the pressure. Okay. So the pressure at this topmost position be P1 and at lower position be P2. So that P1 be the pressure at top and P2 be the pressure at bottom. Now we have the definition of pressure. What? Pressure is equal to force upon area. So I can write force is equal to pressure into area. Pressure is equal to force upon area. So force is equal to pressure into area. So force is equal to pressure into area. Now here F1 is the force. So what will be the F1? F1 equal to P1 into A, where P1 is the pressure acting here and A is the area of this surface. Similarly, F2 is equal to P2 into A. So F2 is here. So as P2 is the pressure here and A is the area, so F2 is equal to P2 into A. Okay, and yesterday also we had derived this mass. We know that density is equal to mass upon volume. So mass M is equal to density into volume. So mass M is equal to density into volume. But what is volume? Area into height. Area into height. So what is area of this vessel? Area of the cross sectional area of vessel is A, and height. This is height. So what is height? Difference between these two, x1 minus x2. So I have written rho A into x1 minus x2. So this is the value of mass. Now the value of F1, F2 and M we have to substitute in this equation 1. So what will come here? F2 is equal to P2 into A. What is F1? P1 into A. What is M? Rho A x1 minus x2. So rho A x1 minus x2 into G. Okay, rho A x1 minus x2 into this G. Okay, now if you see here, A is common in all, so we can take it outside and we can cancel it. So after cancellation of A, what is remaining? P2 is equal to P1 plus rho into bracket x1 minus x2 into G. So this is the expression for atmospheric pressure and gauge pressure of a liquid which is the acting on this cylinder. Note it down. Okay, so now we are going to see the two applications. Okay, two conditions in it. Now here, see this first condition. Here the container is on the surface of the water. So top face of the container is on the surface of water and bottom face is inside the water. Top is on the surface of this beaker and bottom is inside it. So as it is on top, okay, so the pressure here is nothing but atmospheric pressure acting here, because here it is air. So the at top there is atmospheric pressure. So I have written P1 is equal to P0. And here at bottom there is a pressure due to water. So I have written P2 is equal to P. Now use this equation and just substitute this value. Okay. What P2? What is value of P2? P. What is value of P1? P1 is equal to P0. Okay. Then we have rho. This is x2 minus x1. This x2 minus x1, which is given here, that is nothing but height h. So I have written here h and g. So what we get? P is equal to P0 plus rho hg. When a vessel is one part of the vessel, top surface of the vessel or cylinder is on the surface of the water and bottom is inside it. Okay. So what we get? P minus P0. Difference in the pressure. Difference in the pressure is nothing but equal to this height of the, okay, height into density of the liquid into acceleration due to gravity. Okay. Now second condition. What is second condition? The vessel is on the surface of the water. It is on the surface of this water. Now, as it is on the surface of water, the upper part is in the air and lower part of the vessel is subjected to the pressure and the force applied by this water which is there inside the beaker. Okay, so the pressure at lower is nothing but what? P0, and at P is equal to P1. P1 equal to P. Okay, air pressure. So if you put here in that equation, what we get? P2. Okay. So P2, that is nothing but P0. So P2 is equal to P0. So P0 is equal to P plus, now density. As this vessel is in the air, so the density we have to consider of air. So I have written here density of the air into the height of this, as it is above the water surface. So we have to analyze the pressure due to the water. So it is as above, as we are measuring here. This is our axis, which is 0, downside positive, up negative we are considering. So we get here minus d. So I put here minus d into acceleration due to gravity is g. So just simplify, after simplification, what we get? P0 is equal to P minus rho air into d. D is nothing but this distance, height, and acceleration due to gravity g. So this is the equation for the two different conditions when vessel, top surface of vessel is subjected to the atmospheric pressure, and when complete vessel is subjected to atmospheric pressure but the lower part of the vessel is subjected to the pressure due to the liquid in the vessel. Okay, note it down.